So let's finish off this second and last example for optimization problems. So now I have a cylindrical can and it can hold 500 milliliters of sliced peaches. So hopefully when you're reading that, it's talking about some keywords here would be hold, right? It's holding 500 milliliters of sliced peaches. That would be talking about volume, right? It's asking you to determine the dimensions that are, so it's only asking for the dimensions again this time, that are going to minimize, though, the surface area of the can. So here we have another minimize question, and it gives you this hint here that 1 milliliter is equal to 1 centimeter cubed. Because if this is talking about volume, so let's just talk about that, right? Volume is always cubed, so that doesn't represent the volume yet. So the 500 milliliters, to convert it, 1 equals 1, so 500 equals 500. I'm just going to convert that into centimeters cubed there to be, I should say, volume. Now that's not the first equation we should come up with though, because it's always what it's asking us to optimize. So we want to minimize the surface area. So what we need is a surface area equation, right? So again, first is always to do the drawing. So maybe let's start there. Let's just write down here that we need a surface area equation to start. And then if I had two variables, I know what my second equation would be, right? So we'll get there. Let's do our drawing here of our, maybe I can even put this off to the side so it doesn't take up as much room. Again, you are going to draw probably better than me. Don't know why that's, anyways, so that's our cylinder. And what we need to know for a cylinder when we have our formula is we need the radius dimension and we need our height dimension. Okay. So again, the equations will be given to you. I guess let's first do our let statements here, right? So if we're gonna have a surface area equation, then we're gonna are you gonna make it SA? I just feel like two variables beside each other might be a bit more confusing. So maybe just let that be A, right? So let A represent the surface area. You can say of the cylinder, but since that's the only shape we're talking about, let A represent the surface area. Now surface area would be, we've got our units as centimeters, area is squared, right? And we have two other variables there. So we're going to let R, little r, represent the what? Radius, again, of the cylinder, and that would be in centimeters. Represent the radius in centimeters, and let H, I'm just gonna say here, represent the height of the cylinder is kind of implied in centimeters. So then when we talk about our first formula, we already said it has to be a surface area formula. So you would just go ahead to the sheet I give you, or maybe I would put it at the top of the test, and our surface area lookup of a cylinder, right, is 2 pi r squared, 2 pi r squared plus 2 pi r h. So what do we notice here? I have, again, we talked about how pi is just a constant, but r is a variable, it's in our drawing, and h is a variable, and it's in our let statement. So I have two variables. So there we go, I need another equation to substitute in. So two variables, I need another equation, and we've already talked about how in the question it was mentioning. Now here's kind of where it's a little bit trickier because the last question one actually said volume in the question, this one isn't. You need to know by the words holding inside and that I'm filling the cylinder with peaches that it would be volume. So I need a volume. Again, you just go look up the volume formula of a cylinder, which is the area of the bottom times the height. So area of a circle is pi r squared times the height. So pi r squared h. And we talked about also in the last video how you can, but it might be a little bit more difficult for you to isolate for r. So let's isolate for h because I don't have to take the square root of it. So if I isolate for h, and also here, I didn't mention, I forgot here that I should put that the volume, right? I need a number in here somewhere. I can't have three variables, just two. So the volume is 500. So I'm going to change that to 500 equals pi r squared h before I isolate for h. So then if I was going to isolate for h to get h by itself, I would divide by what's in my way, pi r squared pi r squared. This cancels out. And that's all you can do, right? So I'm just going to put h on the left-hand side for no reason other than it looks better. H equals 500 over pi r squared. So that is my second formula that I'm going to I'm just going to try to fit this underneath into formula number 1. Okay, so then formula number 1 here, surface area, when I see h is when I care. So the 2 pi r squared stays 2 pi r squared, but then I have 2 pi r, and finally I have h as a fraction. So that's going to be my 500 over pi r squared. So then here, if I notice, I want to clean things up when I can. I've got a common pi as a numerator and denominator, so that's gone. I have 1 r on top and 2 on the bottom, so I can get rid of the squared. So then that's going to be equal to, I'm going to go back to blue here, 2 pi r squared. Where am I here? 2 pi r squared plus, be careful, that's done. I have 2 on top times 500, both as numerators, so plus 1,000 over r, and that's it. So to differentiate, I don't know if you can see this, if you're watching it yourself, but in the classroom, I don't know if you can see this lime green. So I'm just gonna go back to a darker green. So differentiate, again, it might be easier for my area formula to put the r value on top, right, when I'm getting the derivative. So 2 pi r squared plus 1,000 times r to the exponent -1. Now don't have that that's the derivative yet, right? All I've done is rearrange the area formula. Now to get the derivative, now I can say a prime, and we're doing this with respect to r, right? So the 2 comes out in front and would be 4 pi single r. The negative is being multiplied by the positive 1,000. So now I have negative 1,000 r, and don't forget -2, -1 minus 1. And then I set that equal to 0. So 0 is going to equal 4 pi r minus 1,000 r to the exponent of -2. So, okay, let's just write that out first. 0 equals 4 pi r minus 1,000 r to the -2. And again, when we have to solve for r, that's the only variable for a critical number to get what the radius would be. It might be easier, because we don't like negative exponents, to bring that down to the bottom. I'm just going to clear this. I can't squish it in anywhere. Okay, so just continue on. I would have here, I'm just going to write the next step, right, because it's not that much different other than bringing that exponent down to the bottom. So I have my 4 pi r minus my 1,000 divided by r squared. So I have that as a positive exponent. And then in the last video, again, what we did was I'm just going to put here CD, common denominator, and that would be r squared now. So if I have, hopefully you can see this orange, r squared at the bottom, then I have to multiply by r squared on top, just my left term, right? The term on the left, the right-hand side, but the left side, not the right side, is already taken care of for us, so that I would have a denominator of r squared altogether. And if I multiply the top, it's only times r squared. So I still have 4, I still have pi, but r times r squared is now r cubed, right? Minus 1,000. 4 pi r cubed minus 1,000 over r squared. Set that equal to 0. Again, 0 is just going to be equal to the numerator, right? When you cross multiply. So 0 is equal to, and if I take a look at 4 and I take a look at 1,000, like there's nothing else, that's because again, we're in factoring mode here. So if I know I can pull out the 4, then I'm left with pi r cubed minus what's 1,000 divided by 4, 250. Now I still need to be figuring out what my r value is, right? So if I look, this numerical value, right, doesn't have an r. So in order for to factor, right, this really isn't of concern for me. It's just going to go away. So I can just set 0 equal to pi r cubed minus 250 when I have a constant out in front. And now just slowly solve for r. So by bringing this, for example, negative 250 over, you'd have 0 plus 250. So 250 equals pi r cubed. So what could I do now, right? Divide by pi, divide by pi. Now it's up to you whether you r cubed equals, whether you actually use the pi button on your calculator or 3.14. Again, I believe the textbook and the way I'm doing it, because I've got my answers here in front of me, is I actually use the full pi, because it's no big deal, just 250 divided by pi button, right, equals. It actually took less work probably than punching in 3.14, and it's more accurate. So that was, I had 79 point, and then I cut it off at 577. So then, just sorry, I'm gonna move up here. Then r would equal the cubed root of that. Make sure it's not the square root. Make sure you're doing the cubed root. So our radius would be, I have roughly 4.3. I don't have to put units, but that would be in centimeters, right? So therefore, just to kind of have that in a different color, that's my critical number. I have a critical number at r equal to 4.3. And now I need to prove and check if that's a minimum. So I'm going to do my second derivative test to confirm a minimum. So I just like second derivative test to confirm a minimum. So is my first derivative up here anywhere? No. So let's write out my first derivative where I have everything on top, where I have a negative exponent. So just from prior to this was 4 pi r, check your note from up above, make sure you know where I'm talking about, minus 1000 r to the negative 2, right? That was my first derivative. Now I'm taking my second derivative. With respect to r, the 1 would come in front and be 4 pi, but then I'd have r to the exponent of 0. And then I would have here negative 2 times negative 1000 would be positive 2000 now, right? R to the negative 3, subtract another 1. And then if I want to evaluate when r is equal to 4.3, right? When we were evaluating, we didn't want the negative exponent. So I brought that down below. Plus 2000 divided by r cubed positively, then I plug in r. So that equals 4 times pi, it's just a constant number, plus, so here, plug this in on your calculator, divided by 4.3 cubed. And what do you get? So what I should have said out here, sorry, was the derivative at 4.3, just to be more specific. I would like it if you explain that to me. It just shows me that you're understanding what you're doing, right? And I end up with 4 pi, just to kind of plus this fraction I have is 25.2 roughly. So I end up with 37.8. But again, really all I care about is that it's greater than 0, right? So if it's greater than 0, that means it's concave up. If it's concave up, therefore I have a local min. Again, I can't really fit that in there, but I'll just put up here, therefore I have a local min at r equals 4.3, which is what I wanted, a minimum, right? Surface area, because again, we're talking about a company here that's packaging peaches. They want to have the minimum amount of surface area where they can still hold that volume of peaches. So then for their label, for the glass, for everything, it's costing them less in terms of their cost to package the peaches in those jars, right? So now we just have our conclusion. So we've confirmed a minimum because it's concave up, if you want to write that down, so local min. So in conclusion, it's asking for, go back and read the question, just the dimensions. So the radius, we already figured out, is 4.3, but our units were centimeters. And then in my diagram, I also had height, right? Just radius and height. My height formula, if you go back, is 500 divided by pi r squared when I isolated for h and just had my h equals formula. So plug in r, 500 divided by pi, 4.3 only is squared, and you should end up with 8.6 centimeters. So my height is 8.6 centimeters. My radius is 4.3 centimeters, and that would be your dimensions. It doesn't ask for the area, right? It just asks for the dimensions. If it asked for the surface area, what is that surface area? Just rewrite your equation, right? Area equals pi r squared plus, 2 pi r squared plus 2 pi r h, and all you need is r and h, and you can plug those values into the formula like in grade 9 and get what your surface area is, and just make sure you put centimeters squared. So again, just be careful what the question's asking. So far, these examples haven't asked you to go any further.